Okay, here's hopefully a short video going over the answers to these. Let's see, I'll just use shorthand. What happens to the car at time t equals 1 second? Well, the velocity, so the acceleration that's greater than 0, that's interesting. There's the pen, oh, it's detecting the book. Switches over to less than 0, greater than 1. Okay, so acceleration switches from positive to negative. The car is no longer speeding up but now slowing down, and that's reflected in the slope of the graph. Okay, how does the average velocity compare to its average velocity before and after? Oh, that's pretty good. Okay, let's see. Let's just label it. We could call this average velocity number 1 was plus 10 meters per second, and the average velocity number 2, oh, is still positive. Okay, it's going forward but speeding up, and now it's going forward but slowing down. Oh, it's also plus 10. Did you get that? So for part B, they're actually the same average velocity, up to 5 seconds. What's the displacement from 0 to 7? Oh, from 7. So you have to subtract. You have to subtract 5 meters for that last little segment. Okay. Hmm? Yeah. Okay. Negative 10, and the base is 2. So 2 seconds, 1/2 base times height is negative 10. You're right. Negative 10 total. Awesome. Negative 10. So 1/2 base, here's the base is 5, the height is 20. 1/2 base times height. So you might think it's plus 50, but it's plus 50 minus 10. Right? So plus 40. Plot the acceleration as a function of time. Okay, that's where it's pretty simple. It's increase of 20 meters per second over 1 second. So it should be like, the acceleration should be like plus 20. And then it drops to negative over 1, 2, 3, 4 seconds. It drops back down. So it's negative 5, I think, meters per second squared. Okay, and so it's just, it would drop straight down. That's not going to work. I can't like highlight that thing. Oh, there you go. It's going to be steadily at negative 5. It's the slope of the line. Okay, fantastic. Plot the object's position during this interval as a function of time. Whoops. Okay. So, if we're accelerating up and moving up, it's going to jump up like that over 1 second, but then it's still, let's make that neater right there. It's still moving forward, but now it's accelerating down. So things that are going forward are going up, but accelerating down go like this. Okay. Whoops, and it's a really long curve. Okay, so we're accelerating down all the way. And we've got to hit, oh yeah. So that's what we might do for an experiment. That's actually the point. I expect that to be the top. Could you look at if I asked you to draw a graph of an object that's launched straight up and under the influence of gravity comes to a stop and falls back down. Could you draw me the position, the velocity, and the acceleration graph just out of your head? Most people nodding yes. Okay. So we should actually have the top. No, this is really squished. We should have the top of the parabola at 5 seconds, and then it curves down a bit, but doesn't get very far. Only 10 meters less at 7 seconds. If they say sketch a graph, it can be pretty cheesy, as long as it has the details they're looking for. Okay, good. We're zooming on. Okay, I did the second one, right? I did that one, so we don't need to go over it. Kind of graded myself. Okay. And we continued on because it had our picture here. Okay. How long will it take the cannibal to reach the vertical plane of the wall? So this is actually, this picture goes with the earlier problem. It's similar though. They say to use 9.8. Sometimes for your response they will say 9.8. You should have got, let's see, 5.74 seconds. And this is the height. Will the cannibal strike the wall? So delta y at that point is 22.8 meters. 22.8. Ah. And the wall is 30 meters. So it does. It hits the wall 7.2 meters below the top. Okay? Any questions as to how those came about? Okay. Okay. So we have an equation of acceleration, but we have our v0 and we have our x0, and they're not 0. So they're giving us our same old fun stuff for calculus, but they're not making it easy starting at 0. Okay. So if we set v equals 14 meters per second, that should happen at t equals 2 seconds. Oh yeah, yep. I'd like 3 sig figs, but they're not giving it, so that's okay. Okay. Hopefully you got and discarded the t equals negative 2 seconds. Right. If we had modeled the situation starting earlier, there would have been another point where we had that velocity. But we started our clock late and with different initial conditions. Okay. And then we say when t equals 3 seconds, calculate position, not displacement. And you should get 37 meters positive. Okay. Pretty good? Okay. All right then.